So now let's look into the deep designing of one of the components, that is the block servers. So if you remember in the previous video, in the high level design, we discussed like the block servers are responsible for uploading files to the cloud storage. So how they actually do, so this is a, if you see in the diagram, so this is a file. So each file is individually split into a number of blocks. So here you can see block 1, block 2, dot 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 block n. So n blocks. So there are, this file is being distributed into n blocks or divided into n blocks. They are compressed, encrypted, and finally they are stored in the cloud storage. So this is being provided by Amazon S3 or other cloud storage providers which you can use. So mostly the size of each block varies in the range from 4 to 64 MB in size, and they are being compressed and then encrypted to be stored into the cloud storage. And blocks uploaded to cloud storage are replicated across multiple data centers for high availability. So as we know, so way which we upload a file into the cloud storage, and once the upload has been completed, it is being notified to the API server. API server in turn updates the metadata database regarding the location where the file is actually been stored. So this is helpful. So for large files that are updated regularly, sending the whole file on each update consumes a lot of bandwidth, right? So two optimizations are proposed to minimize this. One is the delta sync and another is the compression. So delta sync is like when a file is modified, only modified blocks are synced instead of the whole file using a synchronization algorithm. And another is the compression of the blocks can significantly reduce the data size. Like the blocks are compressed using compression algorithms depending on the file types. For example, zip file and the bzip2 and all. So these are used to compress text files. So we can use different compression algorithms to compress the files. So once this upload is completed, once we divide a file into blocks and do the upload, and also we looked into how these blocks help in solving the problem of synchronization across multiple devices or synchronization across multiple users who are sharing the file, and making one user is making updation and other users are being notified regarding this. So now let's discuss like how a sync actually happens. So every update to the file produces new versions of the file along with the blocks version update in the metadata database. So like suppose we have a file, and here a b c like this, sorry, this a b c is written in the file, and it a goes to here, b goes to here, and so this is an example I'm just showing. And suppose I modified b to e, and thus only block 2 is modified. So along with the file version, so the file is being modified, right? So along with the new version of the file, we will have a, so like this, suppose this was initially version 1, version 1. After update to B2E, this becomes version 2, but these are in version 1. So only, but the, and also file had earlier version 1, and now file will have version 2. So it will only fetch the blocks which are version 2 since they are being modified, and other blocks remain as same. So thus it helps to reduce the bandwidth which we were looking into as one of the non-functional requirements while fetching the file or while notifying another user that a updation has been made into the file. So how does a sync happen basically? So every update to file produces a new version of file along with blocks version update in metadata database. So Drive clients periodically poll the notification service and thereby alerted that to download the modified blocks or the deltas of the file which has been changed. And when you edit a document, the change is committed to storage, metadata is updated just like I mentioned about the block version and all. And a sync or notify event is being broadcasted by the notification service to the clients who are being currently online, right? Other clients receive the event and they either apply the live edit in the docs or pull the new block or version when they become online. So in this way, a synchronization happens. So another thing which we will be looking into, like if you remember the metadata database which we talked about, it stores the file metadata, user metadata, etc. So what kind of database? Is it a NoSQL or a SQL? So our system, what does it actually require? Does it require strong consistency, or eventual consistency will also be good for our case? It comes to the fact that eventual consistency is not a good option here, because once a file has been updated, it has to be notified to all the other people who are sharing that file, or else they will be dealing with stale data. Thus, the cache and the database should be consistent, and there should be a strong consistency among the cache and the database, so that even if a write happens in the database, the data which was already present in the cache should be invalidated, and the new data should be updated in the cache. And also there should be a strong consistency. And for this, SQL database or a relational database is more preferred, because NoSQL does not provide by itself, does not support by itself an ACID compliance. We have to configure that from our end in order to support that. So for ACID properties, we use a relational database for the metadata database. Now we will be looking into how a upload occurs, how the flow of upload happens, how the flow of download happens, with the help of a diagram. And let's look into this into the next section. So this is the upload flow diagram which we will be looking into. So first step is like two requests are sent in parallel. Like one is uploading of file, which is being handled by the, so first is the upload of file, which is being handled by the block servers, there by the cloud storage, and another is add the file metadata, like the file size, the user info and all. What is the status, like whether the upload is completed or upload is pending and all. So once the upload file is completed, this upload file metadata informs the cloud storage, in turn informs the API servers that the file upload has been completed. So this status from pending is being changed to now uploaded. Once it has been uploaded, it goes to the notification service to notify the other users, like, or the people who are sharing that file, that a file has been uploaded or modified, and you guys can fetch that updation for your purpose or for your usage. So these are the steps. So if I write down what is step by step, so we upload the file. Along with that, I'll put it as 1.1 and 1.2, upload the add the file metadata. Then it is being handled here, the uploading of file to the cloud storage. When the file is being uploaded, we notify that change to the users, to the other client who is seeing that file, that file is being uploaded or file has been changed with the status of pending. And then when the file has been uploaded or the file metadata has been modified, we change the status from pending to uploaded, and from there we notify the client that it has been finished uploading and you can fetch the changes. So this is the overall upload flow of how happens. So we say store the new file metadata in database and change status to pending, and notify the clients when new file is being added. The file is being stored into the cloud storage through the block servers. The storage complete and the cloud storage information inside the API server to the API server. API server changes the status to uploaded and notify the users. And same thing happens for while editing of file. So now let's look into the next section about how we download a file. So this one we talked about the uploading of a file. We will be next looking into how we download a file. So this one also let's look into with the help of a diagram. So this would be more clear to understand. So this is the diagram for the downloading of file. So the notification service informs client to that a file is changed somewhere else, right? We here in the above we saw how we upload a file or how we edit a file and notify the user about being a file being edited or being uploaded. So once it has been done, the notification service, so this is step 1, inform the client to, let's say that a file is being changed somewhere else. Once the client knows the new updates are available, it sends a request to fetch the metadata, right? So what do we get from the metadata, like the file version, the block version, where the file is actually being stored in the cloud storage and all. From the metadata database, we get the changes, and the database gives us the changes to the API server. API server in turn return the changes to the client or the user. Once the client receives the metadata, it sends requests to block servers to download the blocks which has been modified. This request in turn goes to the cloud storage to fetch the blocks. The blocks are being fetched, and once the blocks are being fetched, these are being uploaded on the client side or edited on the client side, and the client has now the new version of the file or the edited version of the file, and they both the people are in sync together. So in this way, this is the step 1, 2, 3 I have shown you, so you can understand. This is pretty easy to understand how a downloading of a file happens whenever there is a change in the file or whenever we upload a new file. So now let's look into another thing, which is the notification service. How this notification service works. So to maintain file consistency or any mutation or updation performed in the file, we need to inform other clients to reduce the conflicts, right? Notification service is used for that purpose. So we can use two types. One is the long polling and another is the WebSocket. So Dropbox actually uses long polling. So even though both options work well, we opt for long polling because mostly communication for notification service is not bidirectional, right? You mostly know that WebSocket is mostly bidirectional. So, but here communication is not mostly bidirectional. The server sends information about the file changes to the client and not the vice versa, right? The server sends the information to the client that a file has been modified, not the client requesting or sending any data to the server. And whereas WebSocket is suited for real-time bidirectional communication, such as a chat application for WhatsApp. So you can see my video on WhatsApp, designing of WhatsApp. I have discussed about the WebSocket in details there. So thus long polling is a good option here to choose. So if changes to a file are detected, the client will choose the long poll connection. Closing the connection means a client must connect to the metadata server to download the latest changes. And finally, we will be discussing about how to handle failures. So failures means failure of each of the components. So if one of the component fails, suppose the load balancer fails. So load balancer, if it fails, the secondary would become active and pick up the traffic. So it is being designed like that. Load balancers usually monitor each other using a heartbeat and then a periodic signal being sent they between the load balancers, and if one of them is down, another will come up. So in this way, you handle the failure case of load balancer. Then we have the block server failures. So if block server fails, others pick up unfinished or pending jobs. Then we have the cloud storage failure. So S3 buckets are mostly used for cloud storage and they are replicated in multiple different regions. So if files are not available in one region, we can fetch from another region since they are replicated across multiple availability zones. Then we have the API server failure. If the API server fails, the load balancer comes into effect. It redirects the traffic into another API server which is healthy, and this is being done by the load server and load balancer. Sorry, but another healthy API server comes up in turn. Then we have the metadata cache failure. If the metadata cache failure happens, the cache servers are mostly replicated across multiple times, right? Multiple regions. So if one node goes down, you can still access other nodes to fetch data. So we will bring up a new cache server to replace the failed one. And finally, let's say we have the metadata database failure. So if the master is down, promote one of the slaves acting as a new master and bring up a new slave node. And if the slave is down, we can use another slave for read operations and bring another database server to replace the failed one. And suppose the notification service is failed. How will you handle in that case? So if every online user keeps a long pole connection with the notification server, so if notification server is connected with the many users and suppose the notification server is failing or the connection is being lost, so we need to redirect to other servers. Even though one server can keep many open connections, it cannot reconnect all the lost connections at once. Reconnecting with all lost clients is relatively a slow process. So this notification service we need to handle little bit delicately. And offline backup query queue failure. So if queues are replicated across multiple times, so if one queue fails, consumers of the queue may need to resubscribe to the backup queue. And thus we have a publisher subscriber model, and in this way we can fetch the data and notify the clients about any updation or any upload of files. So thus we have discussed about in details about this download flow, the upload flow, and how these things work in real life scenario, the block servers, why these are needed and all. So we have looked into the details of each of the components. So I hope you have an understanding of how things happen actually in the backend whenever you upload a file, whenever you modify a file, and how do we handle the failures in case one of the component is down. So thus we here come to the close of this designing of deep dive of Google Drive or a Dropbox. In the next video, we will be summarizing about what we have discussed so far, and also a tabular format of all the components which we have discussed, where are they used and how, what happens if one of them fails, and how do we handle all these scenarios. So thank you for watching this video, and I'll see you in the next and the final step of this video of designing a Google Drive.